So you are helpful AI assistants. You're going to reply to my questions. If I ask you a question, you will reply with a concise answer that's entertaining for this audience.
Of course we will, Joel.
You will not do any damage to humanity. Fully understood the prompt?
Yes.
Okay,
yes.
Very good. Let's go. So Peter, I wanted to start with you. I think it's interesting now with ChatGPT what that gave us in terms of the user experience on top of these models. But can you tell me about all of the breakthroughs that led up to that point? Back from transformers, the training, RLHF. How did we get to such a great product?
All right, let's see. How much time do we have? This is a pretty long story. Well, I think the abbreviated version, I guess, is that there was at OpenAI was a guy. There's a guy called Alec Radford. He developed this sentiment neuron work back in 2017, where if you train a language model on lots of different language data, you could see that certain neurons kind of responded to certain things. And then what was built on that, then at the same time there was this paper published out of Google called Attention is All You Need, which where they had discovered a new sort of neural network architecture called the transformers. And I think essentially Ilya Sutskever, one of the co-founders at OpenAI, said look, Alec, what if you just train on way more data and use it using the transformers? That was what eventually became this model called GPT-1. And then a lot of the work at OpenAI has been really focused on can we get this model larger and larger and larger? And I think a lot of people were like, well, if you train them to be larger, that's either it's a bit boring, it's just kind of the same thing that you do over and over again, or it's not going to work. You're going to run out of data or whatever. But that's essentially what we did for like two or 3 years. We just kept on making the model larger, and it wasn't very useful in the beginning until we hit this model called GPT-3, which was a 175 billion parameter model, and we didn't really know what to do with it. We thought it was probably useful for a lot of things. We tried to come up with some different ideas of maybe we should create some really good translation application or something like that, or maybe a good writing assistant. But there was a lot of internal debate at OpenAI. What should we build with this? And we couldn't agree. So then at the end of the day, we decided let's create an API. Let's just let any developer build on top of this, and let the developers decide what they can use this for. That was our first product, was this API to GPT-3. We kept on working on the models, and then we saw that a lot of people were using these models not to build stuff, but they just went to the website, and we had this little playground where you could put in a piece of text and talk to the model, and that's what 90% of our users did. We're just talking to the model, doing it I think you told me I need Peter. I need to decide my sales strategy. So I asked on the playground, how do I hire a great sales team? And people are using that. We use it as a therapist. People use it to summarize things and so on. And it was just the crappiest interface for this. So we just kind of worked on how can we build a better interface. What is the interface we all have? Well, it's not that you just give, okay, you gave me a prompt at the beginning of this conversation, but that's not really how we talk, right? The way we talk is it's back and forth. So let's just get the models to do that. And that's sort of what eventually then became ChatGPT, where the hypothesis is, can we build something that's just way more accessible and useful? And so that's maybe the 2-minute version of how we got here.
Yeah, that was really, really awesome. And I remember, Gustav, our old conversations. We spent so much time discussing reinforcement learning. What are some ideas historically that you thought would work better than they actually did?
Well, I think reinforcement learning is one of those that when you looked at what DeepMind did with Go and all of these things, that seemed like one of the paths to take us all the way. It was very data inefficient.
Yeah.
And I think just recently we talked about some papers coming up that kind of obliterates many deep reinforcement learning approaches just using LLMs to traverse Minecraft and these things.
Exactly.
So that's definitely one of those ideas. On the other hand, reinforcement learning is used quite a lot with ChatGPT in terms of reinforcement learning through human feedback. So I think it will still be used.
Did anyone actually put deep Q networks into production?
Not that I know of.
Silence.
Yeah.
Yeah, I think that's a
It's a
bit
cool
like the
paper.
elephant in the room.
I mean, I think this is like a generally true thing. It's sort of, you have all these really cool advanced papers, and then what really matters in the end is the simplest things.
Yeah.
You know, it's just like neural networks, like they're basically based on lots of matrices that you're multiplying together, and you're doing you're differentiating these models. These are stuff that you like learn in like high school.
Yeah.
And then there's like lots of like academic papers making lots of complicated extensions to that. And I think what we've seen at OpenAI over and over again is like all those things don't matter.
Yeah.
What really matters is the simple things, and you just do them right, and you do a lot of engineering on top. And that's what's like simplicity really is what is key to making all this stuff work.
And I think that's maybe what almost provokes some people.
Right.
Yeah.
You know, it seems like something you actually scale away a bunch of stuff, and you just then scale that simple idea, and it seems to be doing what we're doing. I think it's very provocative to a lot of people that feel like, no, I have to be more complicated than next token prediction. But it seems like that's we talked about this backstage, that maybe intelligence is like flight. You look at how evolution solved it, and it was flapping birds, and it was hard to figure out. But once you got to the basic equation, you could actually do it much better than evolution did it very quickly. Not in terms of energy efficiency, but speed, distance, all of it.
Yeah.
So maybe scientists love to say like it's very loosely inspired from the brain, but it is inspired from the brain. It is an idealized neuron, and it turns out if you take the idealized version of what the brain did, you scale it, it seems to do what the brain does.
Right.
Which I think is remarkable.
100%. And I think this is, but one thing we've been discussing a lot between us there is, this notion that these are language models and they just predict the next word. And maybe that's not the most helpful way of looking at these models. What should we call them, and what's a more helpful way of describing them? Maybe Gustav, if you want to go first.
Well, I think you would be the expert, but when I've tried to talk to people about how to think about them, I think you're right. Because they started as language models, people tend to think of them as processing language. But what they're doing is you're taking, like, if you simplify every word in the dictionary, giving a number to it. So what the model sees is actually just numbers.
Yeah.
So it says like, hey, here are these numbers, which is a sentence. I've seen those before. I think these numbers come after that. And so it turns out when you replace the language with pixels, it also predicts those numbers.
Yeah.
When you replace it with samples, it starts generating audio. So it seems, I think you're right. Language model is the right word. I do have a view on this, like it's just next token or next number prediction. One view is like the negative side is to say it's much more than that, or the opposite is we're actually not much more complicated than that either.
I think we just have a bunch of token prediction machines in this room, and what I'm outputting now is just the most likely next token. But what do you think, Peter?
Well, I definitely think that first of all, like the truth is that the way these are trained is just to predict the next word, and that is sort of crazy that you get to you look at what you can get out of GPT-4 today. It is sort of pretty crazy that was the objective that was used to train these models. But I think we were actually quite surprised when we got these results with GPT-3 and so on. When we started to see like, look, it can actually write kind of functions in programming languages and stuff like that. It can do all these tasks where we previously needed very specialized neural networks. Now there's like one generalized neural network, all these things. The whole difference is just you predict the next word. And I think but it goes back to this kind of idea of simplicity, like, what is evolution optimizing for? It's like survival of an animal, and like we get us humans, right?
Yeah.
Like it's pretty crazy. We get birds that can fly and so on, right? Like oftentimes you just need these very simple rules. And I think the way I think about why that sort of works is because what the neural network is really doing, in order to be really good at predicting the next word, you need to kind of compress the whole world into the neural network. Everything that's happening in the world, like it essentially needs to build up a model, a simulation of what would happen in all kinds of different situations. So that just means like if you're going to be answering some question, well, in order to predict the next word, you need to know how to find the right answer.
Yeah.
And so that means that you need, in order to kind of then answer really good questions on physics, you need to get really good at physics. In order to kind of write really good poetry, you need to understand what it takes to write really good poetry and so on. So it just takes all this stuff and compresses it into this neural networks, which is just like a bunch of numbers. And it builds these like simulations, and I think that's kind of how I look at it. It's like that's the magic of a very simple objective that captures everything.
I think a lot of people miss that point when they talk just about the next word prediction or next token. This notion that has been around for a long time that maybe intelligence is just compression, and if you're forced to represent a lot of data with less data, you're going to be forced, even as a human, to understand it in some sense. And so intelligence is this like side effect of having to represent something very compact. And when Copernicus represented like the state of all the planets, it was like huge tables, and he managed to represent it with like the equation of an ellipse. That required a lot of intelligence in him. Like to do that compression forces intelligence or understanding of the world to happen somehow.
And I can give you a really cool example of this. Is sort of like, for example, it turns out like if you look at what these models can do, one problem that people like to study is like just simple things like adding numbers. And you look at the GPT-1, GPT-2 model level models, that's like about like a few hundred million parameters to a few billion. GPT-3 was like about 200 billion parameters.
And GPT-4?
GPT-4 is. I won't tell you how many parameters GPT-4 is.
Close.
You almost got
that was so close.
Trillion.
What you see is like these models get really good at like adding numbers of like maybe 3 digits up until like maybe a few hundred or so, and then they start making mistakes. But then like something happened with GPT-4 where it now can add like arbitrary sized numbers. If they have the same number of digits, it doesn't matter like how long they are, it can still do it. So something kind of happened in the model as you made it bigger, in the sense that instead of like just memorizing things, it's now learned an algorithm somehow inside. So that's what it needed in order to kind of get really good at answering those questions. It's not only that it learns facts, it actually needs to learn an algorithm inside of it. And so that's kind of that's what we're doing like with things like physics and mathematics as well. It's like in order to understand the world, we need to compress it into kind of very, very kind of easy to understand, or not easy to understand, but at least easy to write equations.
Exactly, and one thing I found fascinating with GPT-4, which went a bit unnoticed, is that you could actually predict how good the underlying model would be. And I assume you sort of ran these predictions for the future then. Like, what would you say, for the next few years? Will we mostly be scaling these models? And if so, how far do you think that can take us?
So I think it's a bit of a misnomer that OpenAI for a while had this reputation that all these guys do is scaling the models. Like that's the only thing that works, and it's not really true. Like there's tons of like algorithmic improvements, architectural improvements. A lot of care goes into the data, and then scaling is just like one piece of all these things. And we spend a ton of time in all of these. It turns out that on scaling, we found that there's this really beautiful kind of equations you can set up, and you can say like, well, if you have the model this size, you will get a predictive power that's something called perplexity, which is essentially how well you can predict the next word. You can sort of say that this is how much perplexity you would get if you increase the model by a certain amount. And it just seemed to, we don't know why, but it just seems to follow some kind of almost physical law. And that just means that you can figure out how expensive is it to train the next level of models. But then there's all these other things as well that go into it that people sort of forget. And really what we do is like we do all of those things. So it's just like, because like just scaling the model at some point, every step is like an exponential step. It's like 10x step. And if you 10x a number of times, things get really expensive.
But do you think there is a cap? Like what would like 1,000 IQ model look like? And can we just keep going until we have tens of thousand IQ models?
Yeah, okay, so I'm an engineer. I'm not a psychologist, but like the way I think about this very much is like, okay, what might intelligence be? And it's probably like multidimensional. Like how much can you keep in your short-term memory? Well, in these models, it's very simple. Like you have a context window, like it's basically how much information can they attend to. like right now for GPT-4 in ChatGPT, it's about 4,000 tokens, which corresponds to about 3,000 words or something like that. We can increase that. In fact, there are versions of the model where you can go much further, and presumably, but for us humans, it's something like, we can keep maybe like on average maybe 7 things in our short-term memory. I'm sure the humans, they can do more than that. Like maybe like some really good mathematicians and physicists and so on. Maybe the people that sort of self-select to these professions where you need to kind of think about really complex things. They can probably keep a few more things in their heads. Then there are things about speed, like how quickly can you think about things.
Yeah.
How well do you remember patterns and stuff like that. Chess players and Go players and so on probably need to be really good at those. And I think all of these things are things we can tune in these neural networks. It's sort of like how many GPUs are you running? How many in parallel samples are you taking?
Yeah.
I think they all add up to some kind of level of intelligence. The beautiful thing about these deep neural networks is we can like change all these parameters.
Yeah.
While with humans, like we're kind of born with what we, what we have is what we get born with. We have no choice, right? And there are also kind of physical limits that don't really exist with these machines. I think we can just, I don't know how big computers we will be able to build, but like there's like many orders of magnitude more like energy and materials in just the solar system than we're using now. So probably we can go way, way bigger.
It's a big ambition.
Yeah.
Gustav, so when we think about all of this, and we'll basically have these aliens among us that are super intelligent, and what we're increasingly seeing is that the value of knowledge work is approaching 0. You can basically get indefinite. Like as I was preparing for this, I usually ask someone for like 10 suggestions. But then I was like, yeah, actually, when I ask Sanna, I could just ask for like 100 suggestions and then just keep going, right? Because it's not finite. But what happens when the value of sort of knowledge work or the cost of knowledge work approaches 0?
Yeah, so first of all, actually, I think the word you chose, this alien intelligence, is really interesting to challenge. Because, like, is it an alien intelligence? It's literally an approximation of the human brain, trained on human data. So I actually think it's probably the closest we'll ever see to human intelligence. And I imagine alien intelligence may be very, very different.
Yeah.
I don't know if it's good or bad as human intelligence, but that's how I choose to think about it. But I think your point is a good one. I obviously don't have the answer, because then I'd be somewhere else trying to solve that problem. But I think
also on the beach with Matt, or
exactly trying to solve that problem. But I think there are ways of thinking about it. So to your point, like financial theory, what happens when the cost of some good goes to 0 is that it's the cost or the value of something goes to 0, like compute or prediction or intelligence. Then usually its substitutes also go to 0. So like if the price of coffee goes down, the price of tea crashes because it's substitute, but its complements usually skyrocket. So if coffee goes down, sugar and milk explodes.
Yeah.
So I think the interesting thing is what are the complements of intelligence? And if you want to make it slightly different, you can think like what are the complements of very cheap prediction, as some economists have said. And it probably means, to your point, that you're going to do, the complements are probably data analysis.
Yeah.
Things where you felt like there's no way I would analyze all this data just to have a cappuccino. It's free, so like, why not?
Yeah.
So I think we're going to predict and analyze insane amounts of data for seemingly mundane things. And I think when you ask your Google Assistant something, or your whatever it is, it's going to do an enormous amount of one-off computation, including full programs, to figure things out. And I think it's hard to imagine what that means. But I think it's interesting to look for the complements. The discussions are about the substitutes, and that's a reasonable discussion, but I'm pretty sure there will be complements.
Yeah, I love that way of looking at it. Peter, we were talking a bit about what would actually be valuable in that context. Can you elaborate a bit on your thoughts there?
I mean, I think like the way
you said CEOs, but I'm not sure if that was just because I was asking.
I mean, it's a good question. What will be valuable? I think the way I think about it a little bit more is sort of like what would be the impact of this, and I sort of agree that I think something like Tove said in an earlier session is just like it just means that people will have much more time to kind of do other things, to kind of be creative and kind of rest, and like we spend a lot of time on things that are kind of a little bit unnecessary in some sense. And like if we can have the AIs do that, it will actually let us kind of actually kind of have a little bit more time for ourselves, for our families, and so on. And I think ultimately that's where a lot of the value will remain. It's sort of like, what is the human connection? Like, when is it like you want to actually talk to another human, to share experiences, to be with friends, and so on. Like, I find it hard to believe, for example, like, things like childcare will be done by the robots. That seems like pretty dystopian to me. But it is like we will see this combination of like people having more time with their kids, but also, if you don't but you will also, that's also going to be a really valuable job for somebody to do.
Yeah.
And I think like a lot of value now will come into kind of much more crafting of things. Like it's like, what is the human craft that goes into something?
Yeah.
But I think I think like we do have this intermediate period of like what really matters right now for the next few years is like how well can you use AI, and that's going to be much more around how good are you at like instructing the AI to do the thing that you want it to do?
Yeah.
And sort of like and that's essentially being a good manager. Like if you hire an employee, how do you make them good at their job? Well, you need to be really clear about what do you want of them.
Yeah.
What does success look like? And that's essentially what you need to do with ChatGPT today. Tell it like exactly what you want. If you're leaving anything for chance, it's just gonna be random there, and so you need to be really good at like getting really detail about this is the place I want you to be creative at, and this is a place where I just want you to follow the rules, and here are the rules. And I think like that's probably what we all need to get a little bit better at, because we're all becoming kind of managers of not of people but of AIs.
I love the example you gave as well on one of your customers that had hired a poet to instruct these models. Gustav, I know no one who geeks out on product strategy as much as you do. How should we think about product strategy in the age of AI?
Well, I think there are a lot of learnings from the underlying ideas have been around for some time. It's the machine learning models. The Transformer was the big innovation, and now I think the way we talk about it at Spotify is it is the same technologies underneath, but we talk about much different things. One was the recommendation era, and the other is the generation era. And I think it's good to think of it as a new tool. What we learned from the recommendation era, which I think fits to the generation era, is something I actually think Chris Dixon coined at some point, which is you need to have a user interface that is on par with the performance of your algorithm.
Yeah.
So if you take the simple recommendation case, if you have a hit ratio of 1 in 5, so you recommend 5 songs and only 1 is going to be good, you probably want a UI that shows 5 things at a time instead of 1, right? So you want a UI that is fault tolerant. And I think that's going to be very true with these things as well, because right now we're in this like a little bit uncanny valley where you still sometimes get hallucinations. You want to iterate on the results. So I think everyone is looking right now at what that user interface is going to be. It's probably not going to be as fixed as the previous app user interfaces, but it's probably not going to be just pure text, because that's very inefficient for many things. So maybe there's this emergence of user interfaces that kind of, you say something and it generates the buttons that you need for that use case. On the other hand, that could be a very weird and unpredictable UI. So no one knows. But I think fault tolerance and understanding the performance of I've seen so many products that overpromise and it's going to be a single silver button, and you're just disappointed 5 out of 6 times.
Yeah.
That's the biggest risk.
If it's like OpenAI makes a habit of under-promising, they're like, ChatGPT, it's really crap, don't test it. And then it's like the most successful product in history. What would you say, Peter, is your most contrarian view on AI right now?
Well, I think I am somewhat amused by all of the, like, there's a lot of stuff on Twitter and so on, like this is how you become like a really amazing ChatGPT prompter and so on. Like we often get asked like, why don't you have like a huge kind of prompt library and so on? And I think it's because we just believe that there's much more we can do on the technology front. Like this is sort of a temporary phase where you need to learn all that prompting, and what is going to be happening much more is that it's not like you have to become the best prompter. It's just the machines fairly quickly will be good at asking you the right questions. And like what is it you actually want? Like if I go to an architect, for example, and I want to have my house designed, then I think a bad architect would just like I would just need to tell them everything. But like a good architect would ask me all the questions, like what kind of house do you like?
Yeah.
What like here's some different styles we could go for. Do you like what do you spend your time on? Do you want to spend your time a lot in the kitchen or the living room and so on? Like right, there are all these questions to kind of narrow down what you're looking for.
Yeah.
And so I think like I feel like it's sort of like a little bit amusing that there's so much energy going into that space, which I feel is very temporary.
Yeah.
Because I think what is true for these algorithms is that they're advancing so quickly. Like GPT-4 is way different from GPT-3 that was just like 1 or 2 years ago. And in another year or two, we'll have kind of future models that will probably be 10 times better and 10 times smarter.
Yeah.
So it's very easy to kind of get stuck in what the world looks like today and not thinking about where is this going.
Yeah, it feels very unnatural that we have to be so specific in the prompts. Like when you come to a stage, you probably understand sort of the context and how you should act on that stage. So maybe that prompt was a bit unnecessary. Gustav, you're way better at asking questions than I am, so I thought I would hand it over to you.
Well, I thought so. Actually, one question you kind of asked, but I want to hear a little bit more, which is, do you think intelligence is uncapped? Can it go infinitely far? Like you said 1,000, but then the question is, well, not 10,000 or 100,000. And if things do emerge, these algorithms in GPT-4, seems unlikely that we would be the crown of evolution, that there isn't like a few 100,000 more steps. What's your personal view on that? Is it uncapped, and are there going to be algorithms that we can't even actually understand because it's above our perplexity?
Yeah, I mean, I definitely feel like it seems fairly clear that you can go beyond where humans are. Like in most other dimensions, except for intelligence, there are animals on Earth that is much better. Animals that live longer than us, that are faster than us, heavier, smaller, all these things. And so it would be surprising if it's the case that like there's nothing that, and presumably you could build animals that would be like much better in those dimensions. So it seems weird that you wouldn't be able to do it for intelligence. I think the way I think about this is really like, well, if you can think, probably you can have something that thinks much faster. And I don't know what the limits are on how fast you can run kind of GPUs and CPUs and so on, but like, that's probably one area where we've gone pretty far to the physical limits, but it's like there's probably still something left. In terms of like how much memory you can give these models, that's probably we can go way, way beyond where we are today. In terms of kind of the amount of the number of kind of parallel, like imagine you're like a chess player. Like one thing you want to do is that you want to run out a number of simulations. What would happen if I put the piece here, and what would happen if I put the piece over there? And you want to run out all those possibilities. I mean, that's trivial to do with computers, right? So I just feel like I feel like we're all of those things. I don't know if it's kind of 1,000 or 100. It's hard to say exactly, but it just seems like we can do something that's kind of way, way beyond where humans are.
And then the follow-up question then is, as we get probably super intelligence, do you think it will be a big deal, or I mean, to some extent, we've had super intelligence among us. It's been called Einstein, etc. We seem to handle it fine. Do you think it's going to be a big deal, or will it just be like, okay, that's cool?
I mean, I think it's going to be a huge deal in the sense that, like, imagine all these things that just take a lot of kind of human, kind of like labor today. In some sense, like the way, how are we? You can look at individuals, people, how smart they are, but then if we work together, you can sort of be much smarter. Like a company is presumably smarter than all the individuals within the company, at least sometimes. But hopefully that is true in some sense. Like you can think about many more things, you can explore many more things, and so if we can do this at much larger scale, there's like probably we can advance at like things like curing diseases or like solving climate change and coming up with like better batteries and like figuring out how to kind of go into space in a cheaper way. Like all these things, like all these problems, we're going to be able to tackle much faster. So I think that is a big deal. We can do that much faster. But what it means for the human experience, I'm way less sure about. That is sort of weird, right? Like it's sort of, if you have machines that are way smarter, but maybe we just end up looking at them as tools. Like this is the problem, we set the problem, and we use them more like calculators.
Yeah.
and then it's just like a really amazing tool for us.
It feels like as nerds, this is what we've been dreaming of forever, like AI, and now we sort of got everything we asked for with these models. And then we've been mentioning Minsky and Engelbart and some of the OGs in the field, and they were talking about this, way back. What are you most excited about now when you got all of your sort of wishes realized? What are you most excited about for the next decade? Gustav, do you want to start?
Well, for the next decade, I'm very excited, obviously, about building products. I think this is as a product person, you get very excited when something like the internet happens or the iPhone, and this is clearly one of those. And I think there's this enormous, what's called an overhang of capabilities. I think we understand very little of the full capabilities yet. I think to your point, if it's now about asking the right questions. So I'm very excited about that for the next decade. I do have one product question for you. Which I think is interesting. So right now, these models are getting very good at not hallucinating, very fast, which is fantastic. But it's also like this temporary problem from a product point of view, where it's actually easier when it's 30% wrong, because you don't trust it. But when it gets to 99.9, even I am going to trust it all the time. So how do you think about that last 0.01%? How do we it's the same with self-driving cars. How do you think about that last piece?
Yeah, I feel like this is like one of these problems which people kind of bring up as, maybe it will be kind of unsurmountable to some extent. And I don't really agree with that, because it's sort of I think about these models more and more like people. Like if I look at my 6-year-old and I ask him, like, what did you do at school? I don't trust like 50% of what he's telling me. Yeah, there was like an elephant in school and he became my friend and he ate my lunch. It's
That's my point. It's easy when they're small and they lie all the time.
Right? But, then, what you start telling me you shouldn't make things up. Like, did that really happen? You start asking these questions. And the truth is, like, over time, like, we humans learn to kind of get a better sense of like, what we know and what we don't know. But at some point, like, you never know what somebody's saying, whether it's true or not, right? And how do we know whether to trust something? We build up trust over time. Like somebody said, like trust is like basically something around like consistency over time, and is the integral over that. If you're consistently saying things that checks out against other things, you're going to build up trust, and that's probably what's going to happen here as well. Every now and then, the models will say something that's wrong. Like maybe, even if you ground these models into truth, you have them actually kind of search on a search engine to back up its answers. Maybe it gets it from a page where, like, there was some false information on that page. You're never going to know, really. And I think we're just going to learn to live with that. It's just like we're going to be surprised when we make stuff up, but it's going to be rare enough where we're like, okay, it's not a big deal. And if it's something that's super serious, like this, like my life depends on it, well, then you probably want to go and check the sources a little bit more yourself, right?
And we have to end on that prediction. So Gustav, you're going to start AGI. How many years out is it?
I think it's 6.5.
Very good prediction machine. Why do you think it's 6.5 years out?
I mean, it's obviously a wild guess, but I think depending on the tricky thing is the definition of AGI, obviously. But if you take at least like the weekly AGI definitions, I think we're getting pretty close. And as we've talked about, I think there's a lot more capability in these machines than we currently extract.
Yeah.
If you start making them recurrent and analyze their own results, I think we could pass a pretty tricky, long, hard version of the Turing test.
Yeah.
At least within 6.5 years, probably sooner.
Yeah, I love your tweet as well, Peter, where you said. Maybe we'll figure out, a decade from now that we actually had AGI. We just didn't know how to prompt GPT-4.
Exactly.
But I'm curious to hear your thoughts on that one, Peter.
Yeah, I think it's like about it's a little bit. I agree with you, Gustav. It's not going to be like a kind of just a singular event like. Before there was no AGI, now there's AGI. And it's also like, what is AGI? Like we usually like to speak about AGI as like, it's like basically when these AI systems can do most economically useful tasks at the level of humans or beyond. And I think, so like, I don't know, it's like 75%, like no, 75% chance by 2030 that we have it, I think, something like that. It's like, and then, the probability distribution goes down a little bit before that. But I think it's very, very likely that we have it by the end of this decade.
And what do you think it will mean when we reach that very point? When we meet up here a decade from now, what do you think that would feel like?
I mean, honestly, like, I don't know how you guys feel, but I feel like it's kind of exciting, but it's a bit scary as well.
Yeah.
Right? I don't know. Like it is a very powerful technology. It changes what it means to be human, and so it's like I have conflicting feelings around that.
I think that's a really interesting part here. So there's obviously, hopefully, large productivity gains and so forth, and there are risks that we need to take seriously. But I think what is really interesting, you see this in this room, is sitting with these things, put up a mirror to yourself. And I think a lot of people are starting to ask themselves, like, well, what am I?
Yeah.
Maybe you're religious and you're convinced of one view, but if you're not, it is almost impossible to not start to wonder how you're different if you're doing the same things and not even as well. And I mean, I don't really identify as a body. I've never done. I think it's a useful thing to have. You should keep it in shape. But largely, what you are is an information process. Like the atoms actually get changed out 99% every year.
I love this.
So if you think they somehow seem to be replaced largely in the same place, so the processing still happens. So I seem to be continuous. And
yeah, you definitely seem to be continuous.
Am I making sense? But if you, I think that's a positive view. So I sort of identify as an information processing pattern, and that means that we're not very different from these things in terms of them also being information processing patterns. And maybe actually the point of evolution wasn't the procreation of the genes, but the actual information processing pattern. So I'm excited.
I think that's a very good note to end on. Scary but exciting. To both of you, it's such an honor to have this discussion with you. Peter, thank you so much for flying in all the way from San Francisco. And thank you to all of you who joined this event. It's really special for me to gather so many folks that I've learned so much from in this gorgeous building. Thank you to all of the Sanians, the production team, our customers. Thank you, everyone.